All right, let's go and take a look at the graphing the linear equation. So in graphing the linear equations, the main thing that I want you to remember from like your, graphing days is y equals mx plus b. Okay. And then also to understand like how do we graph? So this is what we call slope intercept form, right? We have the b, which represents our y-intercept, and we have m, which represents the slope. Now, again, the slope is basically going to be the relationship between any 2 points on the graph. And that relationship, a lot of times we call like the rise over the run, or the change in the y over the change in the x. But really, the first thing we want to do is find like this y-intercept, like where does the graph cross the y-axis? Because all linear lines, I should rephrase that. All linear lines, except for I guess vertical lines, are going to have a y-intercept. So in this case, you can see my y-intercept is at -4. Now we can write this as a coordinate point, right? X is going to be equal 0, and this represents my y value, which is a -4. So let's go ahead and plot that. And when I go ahead and plot that here, I'm just going to basically create my x and y axis. Remember the x-axis? We did that for like the number line. Well, now it's a vertical. Now we have a vertical axis, a vertical number line, which we'll call the y-axis. So we have 0, -4. So I'll go down 1, 2, 3, 4. Okay, played a nice little dot there. And then now we have my m equals 2/3. So how do we understand when my m is equal to 2/3? Well, basically what that says is between any 2 points, we're going to rise 2, and then you could say like your run is going to be 3. Basically, you're going to run is like you're moving left or right. Now, since this is a +2, we're going to go up 2. And since this is a +3, we're going to go to the right 3. If this was a -2, you'd go down 2. And if this was a -3, you'd go to the left 3. So we can go up 2. So we go up 2 and then to the right 3. 1, 2, 3. Now, the cool thing about writing or graphing a linear line is you only need 2 points, right? Because this relationship remains the same between any 2 points. It's also just important to remember that you can go to this relationship to the right, but you could also do it in the opposite direction, right? So if I go up 2 to the right 3, I could also go down 2 to the left 3. 1, 2, 3, because that's also going to maintain that same relationship. All right. So, because again, like the main thing I want you to take away from that is remember, a negative divided by negative is still going to be a positive, right? So that is what that graph would look like. Now, it's really important to remember that when you are graphing a line, to always make sure you put it into slope intercept form. Now, actually, in this one, you don't have to do it. Well, you don't have to put this in slope intercept form. You can actually solve this using the intercept method. But I'm going to put this in slope intercept form, but I will show you how to find the intercept method here. So let's go ahead and put this in the slope intercept form. And then because there's something I want to explain to you about this one. So to put it in slope intercept form, just go ahead and subtract x on both sides. And you get y equals a -x plus 2. Now, the reason why this problem is like kind of important is because a lot of times students will see nothing in front of the x and they say, oh, there's no slope. Well, no, there is a slope. The slope is going to be a -1. So when you have that minus x, remember that's going to be a -1 times x plus 2. So again, going with the same idea here, we're going to go to a +2. So I'll have my nice x and y axis. I'm going to go up to +2. That's my y-intercept. Make a nice little dot. Now, again, I have a -x. Now, here's where it kind of gets interesting. So we have a -1. Well, if m equals a -1, like what do we do, right? This was easy. This was 2 over 3. Rise, rise over run, 2 over 3, -2 over -3. Either way, whatever worked. But what do you do when it's just a number? Well, remember, you can always write the slope as you can always write a number as a fraction. So -1, or at least a rational number as a fraction. So -1, you can just rewrite that over 1. And remember, that's the same thing as a 1 over a -1, right? So it doesn't matter. Do you want to go down 1 to the right 1? Or do you want to go up 1 to the left 1? That is why that works. If you can go either to the right or to the left, you just need to make sure you adjust your rise accordingly based on the slope. So now I can go ahead and connect these 2 points, and that's what's going to look like. Now, the other thing I wanted to mention to you about this is we could also use the intercept method, or at least identify the x and the y intercepts. So remember the x-intercept, right? Wherever the graph crosses the x-axis, if you look at the y number line, y is going to equal to 0. So what is that value? So the x-intercept, y is equal to 0. So if you put a 0 in for y, it's going to be 0 plus x equals 2. Well, then the x-intercept is going to be x equals a 2. So therefore, that'd be the second tick right there. Now, the y-intercept, we already knew that was a 2 because that's listed right there. And you can see that's kind of represented in the graph as well, right? So just a nice little point, like you could also find the x and the y-intercepts and then connect them. That's what we call the intercept method. All right, in the next example, you could use the intercept method, but again, it works like for this because 2 and 4 evenly divide into 16. But again, I still really like that students have this understanding of being able to identify the y-intercept and the slope between those 2 points. So that's just the way I'm going to do it. You could also do the slope-intercept or use the intercept method if you want to. But if I want to solve for y, the first thing I'm going to do is subtract a 4x on both sides. So I get a 2y equals a negative 4x. What is that? Plus 16, right? And then you just go ahead and divide by 2, and I get y is equal to, so negative 4x divided by 2, that's going to be negative 2x. And then 16 divided by 2 is going to be a positive 8. All right. So again, we have this kind of issue with a number for our slope. So m equals a negative 2. Well, again, we can rewrite that as a negative 2 over 1, which we can also write that as a 2 over negative 1. So just remember, all those are going to work, and they're kind of interchangeable with each other. Then what I want you to do is find the y-intercept, which in this case is going to be 8, right? So it's 0, 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. All right, now in this case, we're just going to do it. I'm just going to do it real quickly. Like, I don't really want to go to the right. So I'm going to use the one where it's going to go, let's see, up to, actually, I want to go down. So to go down, then I'm going to use this one. So it'd be down 2 to the right 1. So down 2 to the right 1. And you can see here, it's a little bit steeper of a line. But again, you don't need to go to the left and to the right like I did for the first 2 examples. Just find 2 points and then connect them, and you are good to go. So I think it's really important to recognize, actually, you know what? Let's just find what the x-intercept is. Let's just have a little fun. I wasn't planning on doing this. But how would we find the x-intercept? Again, x-intercept is when y equals 0, right? So let's do 2 times 0 plus a 4x equals 16. So therefore, that's going to give us a 4x equals 16. Divide by 4, right? Solve the equation. X is going to equal a 4. So 1, 2, 3, 4. Looks like it was, it could definitely be comparable, right? That makes sense that works. So just another way to kind of verify that your graph as you drew it was correct, right? You don't want to have like the same positive slope or anything like that going on.